Hello,
Hi,
everyone.
hello everyone. Hi folks. Welcome to another Learn Live session from Fast Track for Azure team. Today we are going to be looking at it deploying application consistently at scale on AKS or Arc-enabled Kubernetes using GitOps. I know it's a mouthful. My name is Umar Mohammed Usman. I am a principal engineer, part of Fast Track for Azure team under Azure CXP Azure Engineering. Victor?
Hello, so my name is Victor Santana. I work as part of the Fast Track alongside with Omar. So it's a pleasure to be here talking about GitOps. And let's go through the content, Omar.
All right. Thanks, Victor. All right, along with us, we have another amazing engineer from our team, Srini Padala. He'll be moderating your chat. You can ask all your questions through the chat. Feel free to say hi to Srini. All right, today what we have done is we've created a collection, a Learn Live collection specifically for this session. All the links, the content we'll be going through, most of the content is in there. Feel free to scan the barcode or feel free to, once Srini will be sharing this link on the chat, feel free to bookmark this code. So I'm gonna quickly bring it up just in case. This is a collection and you will see the GitOps, how you configure GitOps on AKS and Arc-enabled Kubernetes and all of that, and how you run at scale. That's the collection I'm talking about. All right, let's jump into agenda. First, what we'll do is we'll look into what is GitOps. We'll define the GitOps definition and its benefits of GitOps, what its workflow, how it workflow look like, what are some of the principles of GitOps, and all of that. Once we get the hang of GitOps, we will jump into AKS, Azure Kubernetes Service. Just to level set what is AKS. Our goal is not to deep dive into AKS. AKS is a beast. So we're just going to define what is AKS, then quickly jump into configuring or deploying GitOps extension on AKS. And this is the meat of the session. How you would really, deploying GitOps extension on AKS. And following that, a couple of slides, Victor will be taking over into showing a demo on how you configure and deploy GitOps on AKS. And once that's done, we'll go into Arc-enabled Kubernetes. Again, we'll level set what is Arc-enabled Kubernetes. It allows you to connect any of your on-prem Kubernetes cluster or cluster running on other cloud providers to Azure. So you can monitor and install different extensions on your Kubernetes cluster running in other environments. And once you connect your cluster to Arc-enabled Kubernetes, we'll talk about how you again install GitOps extension on any of those on-prem or other cloud provider Kubernetes, how you would install GitOps on that. And today, for the purpose of demo, we will be looking at it. We have AKS running on Azure Stack HCI. This is simulating you running a AKS cluster in on-prem. Again, believe me, you can run AKS not only on Azure. Now you can run AKS on your on-prem as well. It's pretty cool. Finally, we will look into how you can deploy application consistently at scale. It's great. You have one cluster, you're configuring GitOps extension, you're connecting to repo. That's great. But how do you deploy? How do you do this at scale, at massively? You have 10, 15, 100 cluster. How do you do this consistently across multiple clusters? That's what we're going to look at in the last deploying application consistently at scale. So it's a lot of points. In terms of learning objectives, again, like I said, we will learn what is GitOps first and what are some of the benefits, principles, and all of that. And also we'll look into how customization. Flux has its own customization object, and we'll look into how that works as well. And we'll look into how configuring GitOps on AKS, and we'll jump into Arc-enabled Kubernetes, understand Arc-enabled Kubernetes, how you configure GitOps on Arc-enabled Kubernetes clusters. Finally, how you deploy application consistently at scale. So that's the learning objective. With that, let's quickly jump into GitOps. What is GitOps? The definition of GitOps is a way of implementing continuous deployment for cloud native application. Okay, let's break that down. GitOps is a way of implementing continuous deployment. It is if you know the traditional CI/CD DevOps process, CI process builds your application. CD process is the one, continuous deployment process is the one which actually allows you to deploy the application. So GitOps affects the CD process. It doesn't affect the CI process. CI process continue to be the same. And it targets cloud native application. Cloud native applications are your application which you have containerized and you're deploying it on Kubernetes. For this context, cloud native applications are defined as application containerized, running it on Kubernetes. Okay. And what are some of the benefits of GitOps? The first benefit is Git is the source of truth for system. Like for instance, sometimes you deploy application on a Kubernetes cluster, and then you would change the cluster, right, through kubectl commands, and you directly go change it. But then what you deployed, what's in your Git versus what's running in a cluster is completely different because you changed it. With the GitOps, that's not the case. GitOps, the Git is a source of truth. You cannot go change the cluster directly. If you even change using kubectl commands, it reverts back. The GitOps will revert back. So Git is a source of truth. Whatever it's in Git, that's what it's in the cluster. Okay. And now Git is the single place where you operate. I mean, if you want to change anything, you cannot go to the cluster again. You have to go to Git. You have to really, make changes in your Git repo. And, if you're deploying from a main branch, you have to merge. And for that, you have to go through the approval process and all of that. So Git is where you make changes. You do not make changes on your cluster directly. And all changes are observable. Like you can monitor the changes you have done in the Git, as well as you can monitor all the changes went into the cluster through the Flux commands and all of that.
And Omar, let me ask you something. Based on your explanation, what are the different ways of implementing GitOps with Kubernetes?
Yeah, so good question, Victor. GitOps is a concept, right? You have many ways to implement GitOps, many tools out there in the market. There are a couple of popular ones are, VWorks as a company, which is a CNCF project as well. VWorks has its own GitOps implementation tool called Flux, and which is what Microsoft have adopted for our GitOps implementation for Kubernetes and Arc-enabled clusters. We also have another popular tool called Argo CD. That's another one if customer wanting to deploy GitOps on their, implement GitOps on their own, and they can adopt Argo CD as well. So our managed offering again is based on, VWorks Flux. Okay, so we're going to go into now GitOps principles. Let me just go in here. So here are some of the principles at a high level. System state described declaratively. I think we all know declarative versus imperative. Declarative is, you just define what needs to be done, right? You don't tell how. Imperative is how. You need to define how needs to be happening, the state. As you know, in Kubernetes YAML files, they are declarative files. So you just say, here is my state, and Kubernetes takes care of the deployment, right? So you define your YAML files, the Helm charts, and all of that. And once you hand over that to the GitOps, and it takes care of the deployment part. You just define what needs to be done, but you don't tell how. That's why its system state is defined declaratively. And also the state declaration versioned into source control. So your YAML files, right, or Helm charts are version control and source control. It's a common standard version controlling it. You can always roll back if you wanted to, all of a sudden you went into production and you realize, yep, this is not working the way we wanted to. I want to roll back to previous version. You can simply do a revert, git revert, and it goes back to previous version. And as soon as you revert, that state will reflect in your cluster. Okay, so all your changes are version control. If you want to revert, you can revert back, and approved changes are applied automatically. So if you know the flow of Git, which we are going to look into it in a minute, you build the application, and once you checked in your code, you issue a PR, pull request, from a feature branch to a main branch, and there's approval process. Somebody has to approve, and you could have your GitOps pointing it to a repo to the main branch. As soon as you approve the PR in the main branch, the GitOps will reflect the changes in the cluster, right? So agents enforce the desired state. GitOps Extension, GitOps, it basically installs the Flux v2 extension on Kubernetes cluster. The agents are really monitoring the Kubernetes clusters. So the agents are monitoring the Git repo. Whatever the states in there, it reflects in there. So it's not a magic. It's a simple agents sitting in on your Kubernetes cluster running, which are monitoring your Git repo for changes. If anything changes, it reflects the changes on a cluster. This is at a workflow at a high level. We're going to look at the visual representation of as well. This is the overall, the CI/CD process, and we'll look into how GitOps fit into the CI/CD process, right? Traditionally, developers write code and push into the Git repo. As soon as they push in the repo, the CI process, continuous integration process, kicks in, and it builds the code and creates container images, push it to any container registry. It could be Azure Container Registry or other container registries, right? It pushes the container registry. And your changes, your YAML files or Helm charts, you issue a pull request from whatever the branch you are in, maybe a feature branch, and you merge that to a main branch where you deploy from. And this is where once you issue a pull request, somebody approves the pull request, and once the pull request is merged, then it triggers the update. And this is where in-cluster Flux agents monitoring the repo, takes those changes and applies to the cluster.
So I have a question, Mark.
Yes.
Looking at those 5 steps that you just explained about developers writing the code, the CI builds and push the container registry, pull requests, and the regular approval process in cluster. The agent will go there, watch the repo, and apply those changes. How that would differ from let's say a GitOps versus DevOps?
Yeah, it's a good question. Traditionally, the DevOps process, before the GitOps, the CI/CD is CI process is the same. In GitOps or traditional DevOps, it's same. Continuous integration builds the application. In the traditional CD process, the agents are pushing, basically, right? Or DevOps, your Azure DevOps agents or GitHub Actions are pushing the code to the cluster, right? It's pushing and it's deploying the code to the cluster. Whereas in the GitOps world, you're basically, the agents are sitting there and pulling the code, pulling the changes, YAML file, and also pulling the container images from the container registry. So that's the push. The traditional CI/CD process is pushing the changes to the cluster, whereas in GitOps world, it's the agents are pulling the changes. And there's a good benefit there as well. There are some times where you have I think we all know we have to deploy a private AKS cluster, right? Those private AKS cluster endpoints are not accessible publicly. So now in this case, to deploy the in order to deploy through a traditional process to a private AKS cluster, you can't, because you need to now have an agent sitting on DevOps agents or GitHub Action agents sitting on your virtual network, basically, as waiting for the CD process to kick in, and it's pulling and deploying it. Whereas in here, you don't need any agent or anything like that. The Flux agent sitting on running on your cluster is pulling the code into a private cluster. It's pretty cool. That's one of the
Yeah,
changes here.
I I agree with you. It's really nice and it sounds like it's revolutionary and
Yes.
it's also give me the impression that it's going to speed up my development a lot from the perception of who and where the responsibilities are. And with that being said, does it change anything regarding about the approval process with GitOps?
No, no. The approval process is almost same in a traditional DevOps or in GitOps. The approval process is exactly same, Victor. Right? As we know, approval process is approval process. You make changes in a feature branch or any branch, and you issue a pull request. And your traditional approval process, you go through the traditional approval process of approving changes. So there's nothing changes in that.
Cool.
All right. So with that, I will look into, we just saw in the words, and we're looking at an architectural diagram wise how this flow works, right? And we will look into single tenant, and then we'll look into next slide, we'll look into multi-tenant. In single tenant, basically, like I said, again, a developer on the left-hand side makes builds application, commits the changes to the repo, and at the same time, as soon as you commit a change to the repo, your CI process kicks in, builds a container image, pushes to the container registry, in this case, Docker container registry, and this is the Kubernetes cluster in the dotted line, and we have Flux running in here, Flux CD. It's monitoring the repo, right? As soon as some changes occurs in this repo, it goes and pulls the YAML files, Kubernetes YAML files, or Helm charts. And at the same time, the YAML files are referring to your container images sitting in a container registry. It pulls both of them and applies to Kubernetes. So, and again, as you see on here, big red cross mark, that you cannot do a kubectl apply. You cannot directly make changes to Kubernetes because now GitOps agents are really deploying the changes. You can go ahead and make a change using kubectl apply command. You can change the service file and deploy something new and all of that. But then as soon as the next interval, the agents are running, whatever the frequency you define, 2 minutes, 3 minutes, 5 minutes, 10 minutes. When the next cycle hits, and it's going to come and say, yep, this is not supposed to be the state. What I know, it's going to reflect back what's defined in your repo, and it's going to remove the changes you manually apply. All right?
Amazing.
Yeah, it's pretty cool. This is the multi-tenancy. You always have different personas in the enterprise organization or in any company for that matter. You have, as a Kubernetes administrator, they're responsible for deploying ingress controller or other resources. They are deploying resources at the, for deploying resources which affects all the teams, right? The ingress controller, like you deploy once and you reuse it for a lot of application. But then you have each team, they are owning their own namespace and they're only deploying their application. They only care about that, right? So in this case, here it shows you could have two different repo, and the Flux agents, GitOps extension can monitor two different repos, right? It shows us in the two different repo, team one Git repo, cluster repo. But you don't have to. You can have a single repo, and you can also point to a different folder within that repo as well, right? And the Flux is completely capable of monitoring multiple repos, or it also can monitor different folder in the same repo and apply the changes. All right, so this is the customization part. Customization is another CNCF project. Flux uses it quite a bit. And this is using a Flux. Customization is a Flux resource that represents set of manifests in the Git repo. For instance, let's say you have a repo in a real application. You would have many YAML files or Helm charts and all of that. Now, how do you determine, what order these YAML files needs to be deployed? Sometimes you want to create ingress controller, right? Sometimes you want to create the namespace first. Then you want to deploy your pods. Then you would go on to deploy your services. Then you go on to deploy your ingress resources. So all of these things, how do you order them? Customization, you would create a customization file and say, first deploy my ingress, then deploy my namespace, then you deploy pods, then you deploy service, then you deploy ingress. So you would order them. So customization is the way you customize your Flux deployment. And there are some pretty cool parameters as well. For instance, prune equal to true. What this does is, whenever you have a bunch of YAML files, you deployed it, let's assume that you have multiple pods. Now I want to remove one pod. All you have to do is you go ahead and delete that YAML file. Then the prune true parameter enforces, no more, I don't have this YAML file anymore. I'm going to delete the pod deployment from the cluster. So this is that setting that allows you to customize it.
And Umar, what are the supported types that we have available for GitOps with AKS?
Yeah, so different types of file you could definitely, I mean, Kubernetes YAML file. You can a traditional YAML files, which is what a lot of developers use. Yes, you can use them, and of course, also you could use Helm charts as well. Helm charts, Kubernetes YAML file. So uh, Flux or GitOps extension understands both of those files and it deploys
Amazing.
accordingly.
Cool.
All right. And with that, I'm going to hand over to Victor, and I'll come back and talk about Arc-enabled Kubernetes. Victor, take it away.
Thank you, Umar. So appreciate it so far for the amazing expo. Can you, Todd, please go back to the slides? Umar gonna drive them. Appreciate it. Yeah, so for Azure Kubernetes Service, we are pretty much it's a Kubernetes. So AKS, it is the Microsoft Kubernetes distribution. We have that currently available on Azure, where we name it as Azure Kubernetes Service. It's pretty much a platform with a bunch of clusters, with an API server, etcd, all of that complexity as a kind of service that you can just deploy. You don't have to care about the whole complexity of deploying a cluster by yourself. You can pretty much leverage Azure to go ahead and deploy the entire cluster for you. So we split that in multiple different methodologies, like we put like in node pools, and then we aggregate them in types of nodes independently and different between them. So pretty much in a nutshell, Azure Kubernetes Service, it is a flavor of Kubernetes that we Microsoft own and develop it and support, and we allow that to be deployed on Azure or on-premise throughout HCI, and there are Azure Stack Hub and many other options currently available for you to deploy, including Edge Essentials as well. Yeah, so there are many available flavors in the market. Like I can mention like 2 or 3 more here, like OpenShift, Tanzu, Key3, and many other available distributions. So that's the Microsoft service. And today we're gonna be using on top of AKS, we're going to be using GitOps. And in order to, Umar, if you can go to the next slide, in order, as Umar have been explaining so far, in order to have the Flux as your GitOps workflow and operator to control the entire your entire pipeline together with your environment and the developers going through this entire logic and flow, Microsoft gives you the GitOps as an add-on. You don't have to manually install Flux. You're going to be installing that throughout AKS add-on, and it's such an amazing feature. You're going to see in the demo in a second, where you don't have to care about a bunch of the specifics, a bunch of the complexity of having a new operator in your cluster. Pretty much you just go to the Azure portal or Azure CLI, as I'm going to show you, and then you can say, go under, create a new configuration entry, go under that repo on this branch, on this path, and please apply my customization file from there, and that's pretty much it. And on this slide, we have a really nice uh, steps that you can logically follow to understand how that works in practice. So pretty much imagining that a developer are using, on step number one, are using a VS Code to write his YAML files, the code, and everything else. Once he's done, he's going to do a commit on that. And then that commit eventually going to be pushed to a remote repo. And then once it gets to the remote repo, all the chains, all the code manipulation that he has done and so on is ready to go. That code needs to be compiled, and then your pipeline will kicks in. Let's say if you are using GitHub Actions, the GitHub Actions will kicks in because it has a watcher on that, on your source code repo. It will compile the whole code, and it will generate a new container image at the end of the day. Once that image is ready to be executed, tested, and passed throughout all the possible phases that you might have on your uh, GitHub Actions flow, that image will be pushed to a registry. On this case, Azure Container Registry. Once the image is available there, your GitHub Actions can come back and go to the next step. On this case, the step number 4, it can also go to a Kubernetes manifest file and update the image. So then it's going to say, yep, now the cluster is ready to be using the new image. Everything was tested, approved, everything's ready to go. Now, on as soon as that is approved and everything's done, your commit will be approved, most sometimes throughout PRs, sometimes it's just like a commit that requires approval on that specific branch. And then once it's happened, the Kubernetes manifest file will be updated with the latest image. Then Flux, it is watching uh, those chains on Kubernetes manifest, and then it will apply all of those chains on step number 6 against to the cluster. So that's pretty, in a nutshell, pretty much how the entire process is supposed to happen. We're gonna show some of those things happening in a second. Umar, if you don't mind going to the
Yeah.
next one.
So it's a great explanation on how the GitOps extension using Flux runs on AKS, Victor. So now I'm wondering, I remember, installing Flux manually before we had this GitOps extension, right? It could be pretty painful. And in my question is, what happens when a new version of Flux comes out, or maybe a version? I know we're using Flux V2, right? And when it comes
Sure.
to Flex 2.1 or 2.2 or whatever the minor version comes in, do we need to worry about updating this extension on a cluster?
That's a great question, because instead of you having to own the cluster, like own the operator, the Flux operator by yourself and having to keep updating them, we Microsoft are gonna keep updating that for you throughout packs and minor versions of Flux. So we keep constantly uh, updating our add-on to match our extension, right, the Flux extension, to match the current version of Flux. But once that happens, to avoid any breakdowns on your environment or anything that
Yeah.
could harmfully destroy or affect your environment, we do not upgrade to the let's say to the major version of Flux. We will only automatically update the minor version of Flux automatically. And you can also disable, even if you don't want that extension to keep being updated by Microsoft by itself, to keep touching and upgrading the minor version, you can disable that option as well and just say, don't do anything, I will take care of it. That's totally fine. You can just go on Azure and update whenever you want.
Awesome, awesome. So you can treat that as a past service, let Microsoft or Azure continue to update the minor version. If you say, nope, I don't want it, you can say, that's the default behavior, by the way, manually updating those minor versions. If you don't want, you can say, I don't want this to be updated. You can set that to false using parameter, and we won't update it. We won't touch it, right?
Definitely, that's the default behavior.
Awesome, awesome. Thanks, Victor.
Amazing. If you okay, now if you look at the on the slide right now, we have the command to deploy GitOps extension on AKS. So what that command does, it's an Azure CLI command. Prior to that command, we expect that you have already a cluster, an AKS deployed, and also you have authenticate your session throughout AZ login. Assuming that you are signed in, this command line, you are saying go azk8s configuration flux create. You are creating a branch new customization entry to your cluster and telling the cluster to keep watching a repository. Then you have to define the specifics. But before we keep going further, one thing that it's very important to mention, as soon as you create the first Flux creation, like as soon as you do as soon as you run this command at the first time, the Flux operator will be deployed to your cluster. So pretty much as soon as you run that command, Flux create, the operator will realize, I mean, there is an extension manager that we're going to throw that in a second, but pretty much it's going to see that there is nothing running in the cluster, and then we are going to deploy the operator for you. Then you have to define resource group, what is the name of the cluster, the name of the configuration you would like to use, the namespace inside of the cluster that you would like to be touching, and then you can say cluster type. The cluster type, it is, if it is set to managed clusters, that means it's a cluster that it's being managed by Microsoft, and then it's an AKS cluster. If it says there are some other parameters to cluster type, Umar gonna cover
Yeah,
that when we are going to
like a
talk about
connected
Arc.
cluster, right?
Yeah, it's going to be connected clusters right there. Thank you, Mark. And then if you go on scope, you can scope like kind of permission to Flux where it can behave. You can use scope of as namespace or the entire cluster. Since it's a demo, we are going to use the entire cluster, and then whatever your changes are happening on your Git repo will reflect to the entire cluster. Assuming if you delete a namespace, the namespace will be entirely deleted. Then you can define an interval. Interval, it is how often you would like to the reconciliation to happen. So as Umar mentioned, the reconciliation keep going, right? The operator from Flux keep going to the GitHub to see if there is any change. If there is a change, that change will be reapplied to the cluster. The reconciliation interval by default, I believe it's 10 minutes. Here, for a demo purpose, we are setting to 2 to make it a little bit more often and faster, so we can show in the demo what are the benefits and how that works behind the scenes. So, and the parameter branch, it is like on if in your repo you have multiple branches. Here we are using the main branch, and that's pretty much whatever changes on the main, we're gonna try to reflect that on the cluster. Then you have to define if you are going to use Helm as your main kind of packet management on your repo, or if you are going to use customization, for instance. On our demo, we are using customization, so we are doing dash dash customization, whatever name for that customization that I would like to name it. Then the path of a folder inside of my Git repo where my files will be located. On this case, my kustomization.yaml file must be sitting under that folder. I will show that in a second. I'm, as Umar also explained it really well, what prune means. I'm using prune true, meaning if I delete or change something or delete a file pretty much, uh, that deletion will also happen on my cluster. And for the customization, you also have the same concept of sync interval that I just explained it. So we have two parameters for interval, one for the customization itself and another one to the entire cluster looking to the repo. Uh, Going to the next slide, Umar, please.
Yep.
There we go. So here is a huge, extensive, like I would say, we are exploding the previous explanation on this slide, where we have a cluster administrator that it will be executing the command to, let's say, create a new GitOps or Flux configuration entry to your cluster using the command that I just mentioned on the previous slide. That command on step number 2 will be going against to the Azure Resource Manager. Then Azure Resource Manager will get the command from the Azure CLI and send to the Kubernetes configuration resource provider. Then internally on Azure, we have the resource provider. We split Azure in multiple resource providers. Here we are focused on the Microsoft Kubernetes configuration. That resource provider will finally store that configuration on a configuration data plane service. You as a customer, technically, you don't have to know pretty much none of those details and parameters, but it's important for you to be aware how that works internally. And then on step number 5, we are pretty much saying, okay, the customer would like to set up a new configuration. We're gonna check if your cluster has if it has everything ready to go, then we're gonna go to the step number 6. We're gonna go and get the version of the container registry, all of those containers that needs to be deployed. I'm talking about the Flux as an operator. Then on step number 7, the extension agent will install the operator into your cluster. So on Azure Kubernetes service, by default, that extension agent will be there, waiting in case someone go on Azure portal or Azure CLI, whatever, to install a new extension on your cluster, extensions that Microsoft offer to you to simplify your life. And then pretty much GitOps, it's one of them. Then the extension agent will it's being like watching if there is a new change under the data plane on Azure, and if there is one, it's going to see what needs to be done. On this case, we are about to install Flux. So Flux by itself, it is a package that runs on ARM. So we are here on this example, on the extension agent, apologize. On the extension agent, we are going to the step number 8, creating extension config. So the extension config, it is all the CRDs, like the custom resource definition inside of your cluster. Once all the resource definition gets created, the extension operator will deploy the cluster itself throughout Helm. So even if you are familiar with Helm and do Helm list and to check all the releases that you have on your cluster, you're going to see Flux will be released, managed by Microsoft as an extension. And then once everything went through, so the entire operator will be ready to go and healthy to be utilized, to start to being used. Since on your initial configuration you said, okay, go ahead, I'm pushing a configuration, we realize it's a new configuration. If the operator is not there, we're going to install it by itself. And assuming all of those things had happened, now we are going to go to the Git repo, download, clone the repo, and do the magic and make everything to be deployed inside of your cluster. Now we are moving to a demo.
All right. So when we look at it, this architecture
Go ahead.
diagram looks, Victor, this looks a little bit of daunting, or
I agree.
but I don't think, like you said, I don't think the customers need to know all of the CRDs and all of that, right? If you wanted to, I think you might probably even show going into this Flux system namespace, and you can see all these CRDs, custom resource definitions being deployed, correct?
That's a great call, Mar. Like that's exactly the beauty of being using AKS and Arc for Kubernetes as well, and relying those extensions. Technically, all of those CRDs, you can see them on step number 8 with this down arrow there. So pretty much you don't have to care about them. It's pretty much it's gonna pretty much read the content, right, of those CRDs and do the magic. So I will show how that looks like in a second on my demo, but
Yeah,
you as a customer, you don't have to care about it.
yeah. I was just going to show this architecture diagram is just coming from right from here. Hold on, let me
Go
just
ahead.
this architecture diagram that we've been talking about in here. It's coming right from here. Let me just show up. And again, so this is where this is coming from, and it is part of our collection as well. And the collection we have, this link is there. And if you wanted to understand this entire flow and all the different CRDs gets involved, installed, all of that, you can take a look at it as well. Okay.
Amazing. Thank you, Mar.
All right. Now
Okay. Now moving to the demo. I'm gonna share
switch it
my
to Victor's screen.
other screen. Yeah, one second. I'm sharing the right window right now. It is this one.
I'm going to stop sharing.
Okay.
Take it away.
Thank you, Mar. Thank you, Todd. Perfect. So now, as we just explained it, since it's a demo, I already executed those commands in advance. So the first command, it's not required at all. But in case you just would like to deploy the extension without having any customization, that could be done by just using the first command. The second command, I am going to a repo. This is the repo that we are using. So at GitHub, my middle name and testflux2.git. So if I will show the content in a second of those files, but pretty much I already execute that command as well. And then it's pretty much going there, downloading everything and applying to my cluster. We are executing those commands exactly as they were on the PPT. I just break them down in two phases, like having a single customization or updating to have, let's say, two customizations just to show you something differently. But once they are applied, pretty much we have the cluster down here on my command prompt. We have the cluster ready to go. So prior to show the cluster, I will show the content of those files. On my left, I have the folder vws-app. And if I click under the file, where is it? I will show the customization itself right here. So we have the customization file. The customization file has the files that is expected to be applied. On this case, under my folder, usually on your repo, you're going to save that file and say under this namespace, please go ahead and apply those files. And I'm creating the namespace itself on this file. I'm creating a deployment and I'm creating a service. How the deployment looks like, this is the deployment. It's a very dummy application and deployment that I just created for the purpose of this demo. What it does is I'm saying keep one single, actually here currently on my lab, it's like this. That line is commented. I will explain why in a second. And then we have just like a regular implementation with my image. Since there is no tag, I'm using latest, the requests and limits that I'm applying to my pod. So this is just like any regular application. I'm defining an environment variable telling my front end on how to approach the back end, as you usually do, and so on. I am also deploying the backend server as well using the same customization file, but now I'm pointing to the backend application. Then I'm deploying two versions of my backend. I have the version V1 and I have the V2, and then I have a service. If I go to the same concept, I have the deployment. This is the V2, same thing going, like it's just like a regular deployment. What GitOps will do, it already did actually on this demo. What it did was once we executed those commands, it went to my Git and applied everything. So if I come here and do K it's the abbreviation of, it's just an alias to kube ctl get pods, and then I will filter just to show the namespace of my application. As you can see, I have a single front end with 3 replicas of my backend v1 and 1 replica of my backend v2. So if I go to my backend v1 here, I believe that's the one. No, that's the v2. It's this one. You can see I have a single. Oh, this one it's 1 because it's pointing to a different folder. That one shows 3. I will explain why it was showing 1. So if you go now and look at the repo, what is the point here? Now that you familiarize yourself with those deployments, I'm going to show you the real value. So I will share my screen one more time. I will change my screen share to share my repo on GitHub really quick. When I go up, this one, is it going to share? I believe it's sharing now. Okay, yeah, this is the repo, and this is the folder structure of the repo. You can access from your home right now if you want to, and then pretty much you're gonna see that content. Throughout this content, what I'm gonna do is I'm gonna go to the VWS backend. Currently, we have 3 replicas. I'm gonna click on this file. And as I mentioned, it's number 3 right here. I will edit this on GitHub Live. I will put 2 replicas. That's it. I'm taking 1 replica down from 3 to 2. I will scroll down and I will do a commit. Let's say changing replicas to 2. There we go. Commit change, done. Now I just sent that change. If I go back to my screen again and share the, right here, we're gonna see the change happening in a cluster in a second. Since my cluster is set up to have 2 minutes of reconciliation, my AKS, the GitOps, it is currently watching the change that I did on my Git repository. And in around 2 minutes, we expect one of those 3 replicas here to be terminated by the cluster itself. It's going to take a second or 2 to happen. Yeah, but in the meanwhile, I believe it's like clear for you to understand what's going on. You're gonna have the GitOps watching that repo that I just showed you. I would highly recommend you to open that on your house. Uh, and then pretty much you're gonna see like on that repo, all the folders, all the structures, everything that I have applied on this environment. I also created a file named Learn Live there, where you can follow along all of those things that we did. While we are waiting to the reconciliation to happen, oh, it just happened. Yep, and then since we were waiting those 2 minutes, you can see this pod, it's being terminated. And now that the pod is pretty much gone, if I rerun the command to see the pods here, you're gonna see prior to the change, we had 3 replicas. Now we have only 2 replicas. Whatever change you do on your repo, it's gonna reflect on your cluster. In my case, in 2 minutes, because I set up the interval to be 2 minutes. That's pretty much it. Yep, now we are going to cover about Arc for Kubernetes. Umar, if you don't mind sharing your screen again with the slides, please.
All right, let me go ahead and present. Is my screen up now?
Not yet, I believe.
Hold on.
Yep, I'm trying to watch as soon as you put it live. Let's see if I can see it.
Can you see it now?
Not yet. I believe you were sharing the entire monitor.
Okay, can you see my, oh no, did I not? Hold on. present, share screen, hold on, entire screen.
Todd, can you see his screen? Oh yeah, now I can see it. Now it's perfect. Yeah, but I'm seeing not in the. Yeah, okay, and now it's perfect. Thank you, Mark.
All right, cool. All right. So far, what we have seen, just to summarize, right? We're seeing a lot of things. We have seen what is GitOps, all the definitions of GitOps, and we saw AKS, a brief overview of AKS, Azure Kubernetes Service, and how you would install GitOps extension using Flux v2 on AKS. And Victor just showed a demo of how you would configure GitOps extension on AKS, connecting, pointing into a repo, and any changes you make in the repo that gets reflected in a cluster. So far we have seen it's pretty straightforward, right? But now what we are going to do is we're going to go into Arc-enabled Kubernetes. Why do we need to see Arc-enabled Kubernetes? The reason is you might have clusters running in on-prem or Kubernetes cluster running in on-prem, or you might have cluster running in other cloud providers, Amazon EKS cluster, or GKE cluster in GCP, or VMware Tanzu. These days you have many kind of Kubernetes cluster. You even have an OpenShift cluster running in on-prem, or even AKS running in on-prem. Again, AKS running in on-prem, not in Azure, on Azure Stack HCI. It's a news, right? And you have all these kind of cluster. How do you connect all these clusters running in on-prem to Azure? Why do you want to do that? Why do you want to do that is you wanted to have a single pane of glass. Let's say you have hundreds of clusters or tens of hundreds of clusters. And how do you wanted to have a single pane of glass to monitor all the cluster, to track the cluster, to do the inventory, to see the version, what it's running and all of that. Arc-enabled Kubernetes solves that exact problem. You can take any cluster running as long as it's a CNCF conformant cluster. You can connect to Arc-enabled Kubernetes with a single command. You can connect those cluster to Arc-enabled Kubernetes. Once you connect it, what is the benefit? Not only you can have a single pane of glass, now you can configure all the extensions, right? The extension like your GitOps extensions, which is what we're going to look at today. But not only GitOps extension, you can also configure your monitoring, Azure monitoring. Like you can start monitoring those clusters, remote clusters, or cluster running in on-prem, and you can start monitoring them through Azure portal as well. And you have a bunch of Azure policies. You can apply that as well. And like policies that we are going to look at it, as soon as a cluster is joined to Azure through Arc-enabled Kubernetes, now you're going to configure GitOps automatically and enforce all the application gets deployed automatically on those clusters. It's pretty cool, right? Imagine the retail scenario or clusters running offline. As soon as you connect them and you want application to be deployed in there. So that's what we're going to use at scale using policies. We're going to look at the last. So quickly level set, what is Azure Arc for Kubernetes? Azure Arc for Kubernetes, like I said, is a single pane of glass across your entire cluster inventory. Like I said, you could have hundreds of clusters. You all can see them in a single place in the Azure portal. At scale, you can apply GitOps configuration, GitOps extension onto all these clusters, right? If you configure an Azure policy, then as soon as you connect those clusters to Arc-enabled Kubernetes, then GitOps will automatically get installed, and the application will automatically get installed as well. And it brings in all the Azure management capabilities, monitoring capabilities, applying RBAC policies on all of that, and a separation of concerns of IT and app dev team. As of now, Arc-enabled Kubernetes, it cannot provision the cluster. You still have to provision cluster on your own in terms of lifecycle management, like deleting the cluster or upgrading the cluster. Those are something Arc-enabled Kubernetes doesn't do. As of now, you just have your own cluster. You connect that to Arc-enabled Kubernetes. So how does the GitOps configuration, now we know the Arc-enabled Kubernetes, how does the GitOps configuration works on Arc-enabled Kubernetes, right? Like I said, you could have, you can connect any CNCF conformant cluster to Arc-enabled Kubernetes, again, GKE, cluster, or AKS running on Azure Stack HCI, AWS EKS cluster, Rancher cluster, or any on-prem Kubernetes cluster, right? As long as you use this Arc-enabled Kubernetes command, a single command, you can connect those cluster to Azure. Once you connect those cluster, then the possibilities of so many possibilities are there. You can monitor them. You can apply GitOps configuration. Again, a simple command will connect, will allow you to install GitOps Extension, which is Flux v2, deploys that on any of these clusters, right? Any of these clusters. Once you do that, now you configure again your GitOps extension to point to a repo, which we already seen it multiple times, right? And once you point to the repo, then the Flux extension will start, picking up the changes from the repo and start applying to the cluster. That's the flow. All right. How do you do deploy GitOps extension on Arc-enabled Kubernetes cluster? We make it very consistent. We saw how you do that on AKS, exactly the same. K8s configuration. It's the same command if you go back and how you deployed the GitOps extension on AKS. It's the same for Arc-enabled Kubernetes, right? The key difference in here, you see this one, cluster type is equal to connected cluster. Whereas in AKS world, the parameter was managed cluster, right? That's the main difference. Instead of managed cluster, we are calling it connected cluster because these are the clusters running in other anywhere, but we're connecting them to Azure. That's why you call them connected cluster. But other than rest of the commands or rest of the parameters are same. You're connecting to the repo, the interval, the customization, everything is same. Once you do that, and again, comes back to the same architecture diagram, which again, you really don't have to understand every single aspect of it here. These are, when you execute that AZ K8s, the command, this command, right? AZ Kubernetes configuration command, and this is where it starts, right? As soon as you run that command through Azure CLI, it hands it over to the Azure Resource Manager. And then from there on, all the process starts. And this is the cluster Kubernetes cluster in the bottom. It installs the extension, in which extension installs a bunch of CRDs. These are the same CRDs like when you deploy Flux manually. You will have source controller, customized controller, Helm controller, notification controller. There are a few additional ones which Azure adds, but there are common. Majority of the CRDs are same, right? So that's about it. It's the same architecture, which almost same architecture which Victor had gone through when you deploy the GitOps extension on AKS. It's similar to Arc-enabled Kubernetes. All right, then now we're going to look at it how you would deploy GitOps extension on AKS running on Azure Stack HCI. Again, AKS running on Azure Stack HCI, we connected to Arc-enabled Kubernetes, and now how we would deploy GitOps on AKS running on Azure Stack HCI. Victor?
Perfect. Thank you, Mar. Yep, Todd, if you don't mind switching the screens, appreciate it. So now, as Umar mentioned, what I have here, I have a cluster running in a virtual machine, which technically doesn't matter. Could be any cluster running on EKS, on Amazon, or GKE, on Google, or on-premise with your OpenShift, or whatever VMware, Tanzu, or Linux, or vanilla Kubernetes distribution that you would like to be using, whatever flavor you have in the market, you can pretty much join that cluster to Arc. So once you do it, let me try to make my screen a little bit bigger. So once you have joined the cluster to using Arc for Kubernetes, pretty much you're gonna have this new entry. So the name of my cluster is this name right here. When I click on that cluster, you're gonna see all the specifics of my cluster. When I click GitOps, this is what happened. I initially join my cluster to Arc-enabled Kubernetes. Once it's joined, I executed the exactly same command that Umar just shared with all of you. And then when I went through the portal, saw my Kubernetes Arc, I can go down here, click on GitOps. It is the same experience for AKS as well. And then you can see my configuration setting. If I click on it, it's gonna show the status of the configuration, the repo from where I'm syncing everything, all the details about my sync interval that we already explained in the past. I'm using Flux v2, and there are two customizations on this same configuration entry. When I click configuration objects, you're going to see all the configuration objects. The one that I just mentioned on the overview and the two customization. If I click customization, you're going to see the specifics of it. If I click on one of them, you're going to see the name, the path, the sync interval, and everything else that I set up, including prune and so on when I did the command line. The intention here is just for you to be aware that you can do all of that throughout Portal as well. I will also take the time and show that using Kubernetes. So if I go down here, I have a Kubernetes deployed on my environment. If I click here, this is the same one where you just saw the demo. So the experience of using Arc for Kubernetes and using AKS, Azure Kubernetes Service, it's pretty much the same. We expose the cluster in the same way. If I go to GitOps, since I executed the same exactly command on both clusters, the AKS and my on-premise cluster, all of them share the same settings, same everything, but they are two completely independent clusters. Now, with that being said, I will stop sharing this screen and I am gonna share the cluster itself. Let me know when you can all see. Okay, so I believe you can all see my screen now. No, not yet. Uh, Todd, if you can share my screen again, please. Let me know when you have done, if you can. Do I need to stop share and share again, Todd? I don't know. I will stop sharing and try again. Let's see. Stop sharing. Share screen one more time. Entire window. This one. There we go. Let me know, Todd, when you can do it. Mark, can you see my screen on the... Okay,
Now I
now it went. Okay, amazing. Appreciate it, Todd. Thank you so much. Perfect. Okay, as we just explained it, so we executed the command to to use Arc for Kubernetes. So we use this command right here using the connected cluster as Umar just mentioned. Then I updated the command to use two repos and so on. And pretty much now we have two clusters. If I do k get it k again, it's just the abbreviation of kubectl. So I can do pods and the namespace where I have all my pods. Look at the amount of replicas I have to my backend. I only have two replicas here. Guess what? Since I'm sharing the same Git repository, you can centralize as many clusters as you want. Rather, that would be an OpenShift, EKS, AKS, on-premise, in the cloud, the way you want. As long as those clusters are joined, the Arc for Kubernetes, and then you set up GitOps using those commands that we just give it to you, you're gonna be ready to go. pretty much whatever change I do in one cluster, that will be reflected to all the clusters in the same environment. Another thing that I would like to show you is the configuration drift. So we just prove that both clusters got set up at the same time. Since I did the change there, when you watch it, the change, when I was changing the amount of replicas when I was talking about AKS, so now it's only 2. I will edit, I will do K, edit, deployment. Actually, it's, let me do, I believe I saved the command here just to make my life a little bit easier. Uh, scale? No, I did not. Okay, so if I go here, K, let me see, scale. Okay, I save it. So prior on the AKS deployment, I did cubes. I went to the file itself on my Git repo and changed it to be 2 replicas. I will move it back to be 3 replicas. Look what's going to happen. Now I'm saying, please scale my cluster to 3 replicas. If I go back here and watch the changes, we are seeing a branch new replica. It's being deployed on my cluster. Now I have 3 replicas. It shows a bunch of numbers here. Sometimes it's ugly to see. I will run the command again. Now I am back to 3 replicas. But wait a second. What's going on? It's been terminated, right? The point is, if you are using GitOps with Flux v2, you have the configuration drift on top of it. What that means, if you change something in your cluster, as Umar was explaining at the beginning of the presentation today, if you change something in your cluster, the reconciliation will happen based on the interval that you have defined. And as soon as it reaches that interval, it will reapply all of those changes to the cluster, and then it pretty much are terminating the pod that I just increased. So with this command, I increased from 2 to 3. Now I went back from 3, sorry, I scaled down from 3 to 2. Now I try to scale up from 2 back to 3, and it terminated the pod that was just created, right? So this pod was the one that got created. Down here we see it got ready, and then in less than 2 minutes, I mean, it was less than 2 minutes here just because it's a cycling, right? So it might take at maximum of 2 minutes, but it can happen earlier in those 2 minutes interval. That's pretty much it. And then you have the configuration drift. Uh, Let me see. Yeah, so let me go back here on the other screen. 1 second. Okay, so another, I will show that again just for to make it clear. I will do one more change on the, let's see if the sharing screen is going to help us now. I will share my website one more time. This one. Let me know when you can. Okay, thank you, Todd. It's working now. So I will go back here and I will increase this number to 5. And let's see what's going to happen in both clusters at not exactly in the same time, because it's going to be recycling 2 by 2 minutes. I will put number 5 here now. I will say increase replicas to 5. Save the change. Done. Now, if I go back to the cluster right here, and if I let me, yep, amazing. You all gonna watch the change. So I change it to 5. I will do the same thing on my other monitor. Nobody gonna be seeing anything for a second, but you're gonna see the output at the end of the day. I just executed the same command. This is my AKS on HCI cluster. As soon as those 2 minutes interval pass by and it realizes there is a change on my Git repo, the change will reflect here. It's gonna add 3 more replicas since we had only 2. And in the other screen, I am doing the same thing. I'm gonna share that
Hey,
in a
Victor,
few minutes. Go ahead.
I was told that maybe you want to zoom in a little bit.
Of course. Ooh, this one?
Yes,
There
yes,
we go.
I think it messes up your.
No, that's okay. I can move it left, but that's fine. There we go. We can see all of those pods are actually being scheduled, right? So pretty much what you guys understood what just happened, right? So I changed the Git repo. Uh, then I waited those 2 minutes. Then those 2 minutes passed by. GitOps using Flux v2, the operator went back to the cluster, took the change, come back here, apply those changes into my cluster, and that's it. Now I will stop sharing this screen and I will share the other one again. 1 second. I will share the AKS now. Now you are all seeing my AKS cluster. And as you can see, I let the command running and the same thing happened. Prior to that, we have those only those pods here. Then as soon as the GitOps, the Flux took the change, it reapplied the change, then it was on pending state until it got initialized, scheduled, and now I have all 5 replicas. So if I re-execute the command, I do have 5 replicas of my pods in both clusters at the same time. And if you are wondering, like, should I uh, after you have joined all of your clusters to Arc for Kubernetes, and you actually cluster by cluster execute those commands or go into the portal one by one to set up that and have it done like once for all in all of those clusters at the same time, you're gonna see the answer right now with Umar. Umar, go ahead. And
All
let's
right,
go on how to do that on scale.
all right, perfect, perfect. Okay, how do I share my screen now?
I can see your screen.
You can see my screen? Okay, cool,
Yes, I can.
cool, cool. All right, perfect. Looks like there was a question.
Go to the presentation mode as soon as you
I'm
start
going
talking.
to.
Oh, okay. Apologize. Go ahead.
There was a
Sorry.
question. Srini had bumped it up, and I think he's probably answered the question. The question is, can multi-cluster deployment be done using Flux? Okay, so that was a question. And I think the question is a bit vague, but I'm going to answer it with what I understood. Yes, which is what we're going to look at it now. Deploying Flux on a multiple cluster, using the policies concept is what we're going to look at it. Maybe we could, do you understand the question in a different way? Can multi-cluster deployment be done using Flux? What do you think, Victor? Is that
Yeah,
what we're talking
if
about?
yes, I just as you mentioned, the question was not so descriptive, but just looking at the question, it gives me the perception of deploying the same application in multiple clusters throughout GitOps, because we already mentioned at the beginning of the presentation that Arc for Kubernetes currently does not deploy the cluster for you. So you have to, prior to join the cluster to Arc for Kubernetes, you have to manually join the cluster, right? Once it's joined and then it's going to be exposed to Azure, then you can rely on all of those things that we are saying. And then, yes, the answer would be yes. Yes, you can use multi-cluster, single repo, and deploy all of them at once. And that's exactly what I was demonstrating a few seconds ago.
Okay, cool, cool. Thanks, Victor. All right. So now what we have seen is we have seen how you can configure GitOps extension on AKS. We also seen how you configure GitOps extension on Arc-enabled Kubernetes. In our case, we looked at it Azure Stack, AKS running on Azure Stack HCI. Okay. Now, This is great. You configure all these two clusters manually. In every cluster, you manually configure. What if, as a you as a sometimes you as a Kubernetes administrator or an application developer, I want anytime somebody is onboarding a cluster, they're creating a Kubernetes cluster, or they are connecting an on-prem cluster to Azure, I want the GitOps extension to be automatically deployed, and also my application should be automatically deployed. Like this is the case of at scale. How do you manage tens of hundreds of clusters? How do you do that? This is the answer. The answer is basically you use Azure Policy to apply your Flux v2 configuration at scale. Again, like I said in here, you could apply this Azure Policy, which is deploying Flux v2 configuration extension as well as your configuration on AKS or Arc-enabled Kubernetes, right? It could be any number of cluster. And how you do that? You would go ahead and create a policy. The policy, there are many policies which I'm going to show in a demo in a minute, which is configuring Kubernetes cluster with Flux v2 configuration using public Git repository. There is one with SSH, one with HTTP. There are different policies. You pick those policies and you assign that to either to a resource group or to a subscription or a management group. Management group is nothing but a collection of one or more subscription. You take the policy, you assign to the resource group, subscription, or a management group. As soon as somebody creates a cluster in this resource group or in any resource group under this subscription or at any subscription under this management group, as soon as they create a cluster, and the policy will create the Flux v2 configuration. Right? It's as simple as that. It creates a configuration, it configures the repo, your whatever the Git repo that you are pointing it to. Then whatever it's in that repo, it's going to get automatically deployed onto the cluster. Perfect example is you as a Kubernetes administrator, I want an ingress. As soon as somebody creates a cluster, I want to assign some Kubernetes policies or an ingress controller to be deployed, right? You would simply go ahead and configure such way as soon as somebody onboards a cluster or connects a Kubernetes on-prem cluster, and it will start pushing those policies and it starts creating, it deploys extension and all of that. It's that simple. This works for one cluster, two cluster, hundreds of cluster. It works for it. Okay. Let's quickly look at the demo. Before I go into the demo, this is that page. It's in the collection available. Deploying application consistently at scale using Flux v2. Everything what I explained, it talks about how you create a policy assignment, how you verify the policy assignment, and all of that. That's the steps we're going to go through now. Okay. So let's look at the portal. So what you do is you go to the Azure policy. My portal is just hanging in, it's really slow. But if it's slow, then I'll quickly show you where I am. If not, right, see, it's just spinning the wheels. You go to the Azure policy. On the left-hand side, you go to the Azure policy. I clicked on it, it's spinning there, and you click on definitions. Yeah, it's for some reason it's slow. So that's why I have the definitions already clicked on in here. And what you do is you would have a lot of categories of policies. There are hundreds and hundreds of policies, right? What you do is you would come and drop down this, click the select all, uncheck everything, only select Kubernetes. So now you have only Kubernetes policies, right? So, and this is where I was talking about, there are different policies you have. And what the policy that I'm going to be using it is configuring Kubernetes cluster with a specified GitOps configuration using no secrets, right? And again, this is for demo purpose. You don't have to use this one. You can use with SSH. Same policy with SSH secrets or HTTP secrets or local secrets and all of that. So I'm going to just quickly show you this. You select this policy. Go
Umar,
ahead.
would you mind zoom in just for a second?
Yes.
Let's do Control plus 2-3
Yeah.
times there. Might be enough.
Go. Hold on. Oops.
There we go. Too much?
Too much.
Yeah,
Yeah.
perfect. That's perfect.
Okay, cool. Yeah, this is that policy, right? And again, yeah, so this is that policy. And what you do is once you selected this policy, configuring Kubernetes cluster with a specified GitOps configuration using no secrets. Again, you can do with SSH secret or HTTP secrets. and you click on assign. And this is where you would select the scope. Are you assigning this policy? Is it at a resource group level or a subscription level or a management group level, right? I'm going to select it just for my subscription. This is my subscription. And here you can select, do you want to apply this policy to only a particular resource group, or anybody, any resource group, anyone creating a cluster, a Kubernetes cluster, or connecting an Arc-enabled, connecting an on-prem cluster using Arc-enabled Kubernetes to any resource group under the subscription. It applies to this. And then this is the policy, right? You go to the next, and this is where you would do the regular things, right? And what I'm going to do is, this is where you would give the some name and instance name, and this is where you would, where do you want to install this GitOps extension? What namespace you want to do it? You would do Flux system namespace, and you just give it the configuration name, right? At scale configuration and instance name, git instance name, GitOps.
Pretty much all the parameters that we use in the command line.
Exactly the
they're gonna
parameter.
fill up. Yep.
Yep. You would do the which repo you're pointing it to, right? And you would point to the Git repo URL. And let's say just do something in here for now. And that's it. You go through this task and you assign it. And once you assign this policy, anytime anybody creates, then the policy engine will kick in and start monitoring, your existing clusters, and you can force it and say, you know what, go ahead and apply this policy to existing cluster. Or as soon as anybody onboards a new cluster, it's going to go ahead and push this policy and apply this GitOps configuration to the cluster as well. So that's
Amazing.
it. That's how you enforce it. Go ahead, Victor.
No, I was just saying, like, this is pretty impressive, the way we can centralize all the clusters in a single pane of glass, leveraging Azure, and
Yep.
being able to, manipulate multiple clouds, multiple clusters at the same place. That's amazing.
Yeah. I mean, I've seen a bunch of demos where they talk about, the retail scenario. You have retail
Sure.
stores, right, across the U.S., and each retail stores having a Kubernetes cluster running in their on their retail stores in store. And if you want to make a change, it's pretty painful to go and push changes to every single retail location. But imagine you configure a GitOps on those clusters, right, on those remote cluster. As soon as you push a change to your repo, all those clusters are pulling those changes and
Sure.
updating them. Like an amazing, right?
That's amazing.
Yeah, cool. Yes, we're coming to the end of the session. What did we learn? We learned GitOps and its principles, how the workflow works, how it fits into the overall CI/CD process, and how you can do the customization work, right? How you can customize the GitOps configuration. Then we went on to learn configuring GitOps or Flux v2, which is our implementation, right? And how you configure, how you deploy that on AKS. Then we learned, quickly touched on what is Arc-enabled Kubernetes, how you connect any of your on-prem cluster or clusters running in other cloud providers, how you deploy GitOps extension on those clusters. In our case, Victor showed an amazing demo of how an AKS running on Azure Stack HCI and how you configure GitOps on that. Finally, we learned how you deploy application consistently at scale, using Azure Policy and GitOps Flux v2. Again, this is where you have many clusters, you deploying application consistently. All right. Again, this is our collection, Learn Life collection, and the things that we shared, the demo, the repo, all of the content is here. Feel free to take a look at it. And don't miss our next session coming up. And this is where we will talk about introduction to Azure AD B2C on May 2nd, May 2nd at 10 a.m. Pacific time. Nick McCallum and Bapa Banerjee, those are a couple of amazing engineers from our team. will be presenting Azure AD B2C. All right, any final words, Victor, before we wrap
No,
up?
just to say thank you for the audience to stay until here with us. So appreciate it. Thank you very much. Thank you, Mar, for the opportunity one more time. So it was a great session. Thank you
Thank
all.
you, Victor. It was amazing presenting with you. Thanks, Todd, and thanks, Srini. Thanks so much. I really love enjoying delivering these sessions.
Thank you,
See you
Todd.
all.
Thanks, Rainy. Bye.
Bye.